Hey everyone, welcome back. Hope you enjoyed that crash course video on light, and now you should be able to answer that all-important question, what creates light? Okay, so now we're going to move on to part two, which is a simulation that I found that I think is going to really help you better understand the emission and absorption of energy. Okay, and we're going to use the Bohr model for that. Okay, so Bohr imagined the atom to be kind of like a planetary system, right? So he thought that electrons would travel around the nucleus in distinct orbits. He proposed One of the things that he proposed was that when an electron moves from one orbit to another, it either emits or absorbs energy. Which was the difference in energy between each of those orbits? Okay, so the energy was carried by a photon of light with a wavelength determined by the energy. Because each atom has a unique set of orbits, it had a unique set of energy differences and emitted or absorbed a unique set of wavelengths. So, when astronomers take spectra from an astronomical object, they can see either an emission or an absorption spectra. Using the spectra, they can determine what elements are present in a star or gas cloud. I think that's really, really cool. Okay, so we now know that this is not exactly like what an atom looks like, right? So, but this is a great model to use to be able to understand the absorption or emission of energy. So one of the cool things about this little model is, and you can read it through the introduction and the how-to. Here we are on the interactive. One of the cool things you can do though is you can drag and make these circles, these orbits, different sizes if you'd like. I'm going to move mine to be like super close to each other. And if you notice, it won't let you like overlap in any way. Okay, so it kind of controls that at least. So one of the things that that this simulation allows you to do is to send out a photon of energy and let the electron absorb it and move to a different energy level. Or you can have it emit energy and move down a level. And one of the cool things is that we'll get to see here both the absorption and the emission spectrum. Okay, so let's take a look. Okay, we're going to jump it to orbit 2, and here comes that energy, and there it is. Okay, so that electron absorbed energy in the wavelength of 273 nanometers, okay, to move to that second orbit. Let's jump it again. And there it is. Okay, to move, and here's our absorption spectra. Okay, so that very first jump was right here in the UV range. Our second jump is here in the visible spectrum. Okay, and that wavelength of absorbed photon energy was 545 nanometers. Okay, so now let's jump it all the way to the last one. Okay, can it make that jump? It's a big jump. And there it is. Again, in the UV range, it needed a lot of energy to make that final jump. Okay, so now what we can do is start to bring it back down. And let's see what that emission spectra looks like. Okay, so let's pop it down a level. There it is. And hey, it's that same wavelength. Interesting. Oh, we dropped it down again. And look, it's that same wavelength that needed to jump to that other orbit. And one more time. And it's that exact same wavelength again. And here is our emission spectra, which completely matches exactly to our absorption spectra. Okay, so what I'm going to do now is let you kind of play with this simulation a little bit on your own. I want you, once you've kind of messed around with it a little bit, to come back to the questions. Okay, so you've got some work to do over here on this end. Okay, make sure that you explain your thinking adequately. Okay, and then once you're done with that, I want you to use this website. It's a pretty cool website as well. Okay, it's going to give you the spectra of different elements. So let's see what magnesium does. Look at that. That's pretty cool. Okay, so I'll let you play with that website as well. Answer the questions for that website. Okay. One of the things I'd really like for you to do is see if you can find two elements that have the exact same spectra. Okay, finally, there's a little website here. I want you to read it. Okay, important information there for you. And this is it. Okay, so make sure you read it. Once you're done reading this website, you have your little practice problems. And don't forget, all of this information is testable. Okay, so please make sure that you take care of your end of the bargain. All right, well, until next time, you guys take care.